Welcome back to a new video of the IoT project, from Internet of Things to Artificial Intelligence. In this video, we will review the main concepts we learned in the advanced level of the IoT course Advanced IoT Solutions. Firstly, students will review the main concepts already learned in the introduction and implementation of IoT courses, the concept of IoT and the concept of think. The students also review some of the most popular applications of IoT, from agriculture and industrial processing to healthcare and the smart home, among others. It's important to understand the differences among machine-to-machine, Internet of Things, and Internet of Everything. So the students will learn about them and also about the four pillars of IoT: machine-to-machine, radio frequency identification, wireless sensor networks, and SCADA. Each of these technologies will be reviewed in depth, if they are wireless or wired, and the range. We start with some of the key points of IoT technology. We focus on the physical design, and students will learn that there are two different IoT devices: smart devices, that are those that include a sensor, vibration, precision, acoustic, sound, humidity, etc. And those IoT devices that in fact are inert things with smart devices attached. For instance, when we use RFID tags in order to be attached to, for instance, boxes, because we want to track their position or location. We also review in depth the IoT networks, from those with short range like Bluetooth, Bluetooth Low Energy, 6LoWPAN, 6B, and so on, those for cellular networks like 5G, 4G, or Wi-Fi, among others, and those for long range, some of them specifically designed for IoT technologies like LoRa, Sigfox, or narrowband, among others. The students will also learn that the IoT connections is increasing every year. So we can see in the picture in the right, how these connections are increasing exponentially, from 2015 to 2025, that is expected to have more than 21.5 million of devices connected. About IoT networks, we will also review the different parameters that are key when we have to choose the network technology for an IoT deployment. These parameters are range, throughput, power source, and topology. Depending on our needs, the needs of our deployment, we will choose, for instance, Bluetooth or maybe Wi-Fi. It will depend on the constraints of our IoT deployment. We also got in depth in the protocols. Some of them have been introduced in the previous courses, like IP version 4, IP version 6, or Wi-Fi. However, in this course, we will get in depth in other protocols that are mainly used for IoT, like WiMAX, Low Range View PAN, Ethernet, or those for application layers like MQTT, COAP, XMPP, or HTTP, among others. It's true that IoT needs of a middleware in order to connect the physical devices with the final user applications. The middleware is the cornerstone of any IoT system, as it is crucial for efficient machine-to-machine communication, hiding the heterogeneity of devices, communications, and networks. The middleware provides a set of enabler services such as standardized APIs, protocols, and infrastructure services to support the rapid and proper development of distributed future Internet services and applications. We will learn the different communication models in the middleware. There are 4: request-response model based on client and servers, publish-subscribe model based on producer and broker, push-pull model based on producer and consumer using queues, and exclusive pair based on client and server. We will learn about REST. REST is the acronym of Representational State Transfer and is a set of architectural principles by which web services and web APIs can be designed. It is focused on the resources of a system and how the states of those resources are addressed and transferred. REST APIs follow the request-response communication model, and the REST architectural constraints apply to components, connectors, and data elements within a distributed hypermedia system. It's important to remark that the IoT deployment depends on the cloud. In the cloud, the IoT platform is deployed. In the cloud, the data are stored and managed. So the cloud is the key component of IoT, where the middleware is also included, deployed and managed. We strongly recommend to review the course of cloud computing, where you will learn about the software as a service, platform as a service, and infrastructure as a service as the key services that cloud computing offers for the IoT deployment. Note that in the cloud, the data from the IoT infrastructure are captured, integrated, stored, and preprocessed. And also in the cloud, using different tools, we can map, transform, and clean the data in order to analyze and make decisions. This is what we know as big data and analytics. There are different IoT platforms that offer different tools that permits to manage the data in the different states: ingestion, stream processing, storage, and presentation. Here you can see that for different IoT platforms like Azure, Amazon Web Service, Google, or Synonymy, you can find different tools. For instance, for Amazon Web Services, you have Kinesis Streaming for ingestion, Kinesis Analytics for stream processing, Dynamic DB for storage, or Amazon QuickSight for presentation. So don't forget that for IoT analytics, you need infrastructure, data management, analytics and prediction, and security. Focused on IoT platforms, the students will learn that there are 8 major building blocks of any IoT platform, and the different types of IoT platforms depends on the three levels of technological depth, the end consumer segment focus, and the integration approach. How to choose the right IoT platform? Sometimes we think that it's cheaper to make our own IoT platform, and sometimes we think that it's better to buy an IoT platform. It's easier. The decision will depend on our needs and our requirements. If you have time, money, and a big software program team, maybe you want to build your own IoT platform. But if you don't have time and you need a strong tool, maybe you should buy an IoT platform. Independently of your decision, you have to consider some main features like security, open and flexible architecture, integrability and manageability, robust and scalable IoT infrastructure, IoT case-specific hardware and/or modules, and implementation, integration, and support. Finally, the students will get in depth in some of the most popular platforms. Some of them are open source and some of them are commercial. For instance, Fireware is a framework that permits you to develop your own IoT platform depending on your needs. You need a strong software program knowledge in order to deploy your IoT platform. Amazon Web Service is in the cloud, and it offers a lot of tools for deploying your IoT platform. You have Hadoop, API gateways, data receivers, front-end, data formatter, and so on. Google Cloud IoT is similar to Amazon Web Services. You have a lot of tools also in order to manage your data, publish and subscribe, to do big data and analytics, storage the data, and so on. Microsoft Azure IoT is a commercial IoT platform that is easier to use, easier to deploy than the previous one. It offers a lot of functionalities in order to deploy your IoT platforms with a couple of clicks. Also, IBM Watson IoT platform is easy to use and deploy. It's easier than the previous one, and it's a good way to start when you want to deploy your first IoT platform. Finally, ThinkSboard, that is an open source platform, and it's the platform that will be used in the practice lessons of this course, is included and is studied in depth. The students with different practice lessons will learn to install the ThinkSboard platform. Will learn the main features, how to provision assets and devices, the definition and relationship between assets and devices, and also to pushing data from a device to ThinkSboard, to real-time and end-users dashboards, to do data visualization, threshold and alarms, notifications by email, and IoT data analytics. This is a screen, the main screen of ThinkSboard IoT platform, where the users can see how to use the different functionalities in an easy way. Thanks for watching, and if you have any doubt, don't hesitate to contact us.